All right, ladies and gents, video number 2. Now, in this video, what we're going to be looking at is calculating resultant vectors. That's not how we spell resultant. From non-right triangles. So in the first video, we learned how to calculate the resultant vectors of right triangles. Super easy. It's basically the Pythagorean theorem. We're going to look at examples where they are not necessarily right triangles. So what we're going to be looking at is we have um, let's say we have a sled right here, and we have two people pulling the sled. We have myself here, and we have Mr. Chandler over here. Now, Mr. Chandler is a little bit weaker than me, and he's going to be pulling it with 2 pounds of force. So I'm going to rewrite that. It looks like 21. 2 pounds of force. And Mr. Triticol, being as strong as he is going to be using 12 pounds of force. Now, notice again here, we don't have a right triangle, but I will tell you the angle between the two vectors. The angle between these two vectors is 60 degrees. So I'm pulling this way, and Mr. Chandler is pulling this way. What we want to do is we want to find the resultant vector in our force going this way. So essentially, how strong of a force are me and Mr. Chandler pulling due west, or just directly in this direction? Um, so we're going to check that out. Um, the way we do this, the nice thing is if you're calculating the magnitude, and magnitude, remember, is, I'm going to call this vector A. The magnitude of A is relatively simple, even if it is a non-right triangle. In fact, since it is a non-right triangle, we're going to be using the law of sine and law of cosine. Specifically for this example, we're going to be using the law of cosine. That gives us the formula here. The formula for vector A, or the magnitude of vector A, is b squared plus c squared plus 2bc cosine of A. Again, this should look familiar. The nice thing is about this diagram, when we're working for the resultant vector here, all we have, or the magnitude of the resultant vector, we're just going to use these other two vectors. I know 1, or minus 12, plus Mr. Chandler's is 2, plus 2 times 12 times 2, again, those vectors, cosine. And you guys want to guess what the angle is going to be here? Well, the angle between. This is the magnitude of A. So the nice thing is, remember, when we're solving for lengths in the law of cosine, we can plug all of this directly into our calculator, or substitute that directly in. So we can look at 12 squared plus 2 squared plus 2 times 12 times 2 cosine of 60. Make sure we are in degree mode. Notice here, I'm going to see if I can slide this off to the side. Notice we got that plugged in, and we get 162. Now, I shouldn't have said it's exactly the law of cosine, because remember, in the law of cosine, it's a squared is equal to, right, I should have put that in here, a squared is equal to these values. So to actually figure out what that's going to be, we need to finish up by taking the square root of both sides. And this will give us our magnitude of A is equal to the square root of this is 172, not 162. 172, the square root of 172 which is equal to 13.1 pounds of force. So again, for non-right triangles, trying to find the resultant vector, here I'm going to slide this over. I forgot I left the visual or me in here the whole time. For non-resultant vector, make sure we set up the law of cosine, substitute in properly. What we're trying to find is the resultant vector. We can plug all of this into the calculator at one time and then finish by taking the square root. So make sure you get a picture of this, work through this example, and this will be really helpful for that second assessment for the applications of vectors. Well, I hope this video was helpful for you guys. Have a great rest of the day, and I hope to see you guys in meets, or I hope you guys get to spend some time with your teachers in meets.